Back. So we were working on this, right? So right now I'm unable to get inputs. I'm unable to unpack because right now it's not returning anything. So this has no meaning. All right. Likewise, simulate end games also is returning nothing, none object. So this will not have any meaning. Okay. So let's go through one piece at a time. Okay. So my first, let me understand print intro. I want to introduce the problem to the user. So instead of saying pass, I'm going to print this information to the user. This program simulates a game of racquetball between two players called A and B. The abilities of each player is indicated by a probability. What is a probability? A number between 0 and 1. That the player wins the point when serving. Player A always has the first serve. So now instead of invoking main method, let me invoke print intro function. I'm sorry, I misspoke. Instead of invoking the main function, let me invoke print intro when I compile. Okay, so this line here, if name equals main, is where I get to test each function I type. All right, save. Now let's run. Okay, so it ran and there was no problem. Okay, because this print intro was just a series of print statements. Now let's get inputs from the user. So it's just, remember, what do we need from the user? We need probability for A, probability for B, and the number of games to be played. So get inputs is an easy function. Okay. All right. So define get inputs. Doesn't take any parameters, but it returns the three simulation parameters. So you need to get number of games, probability for B, probability of A. Little a, convert the information to float. Float input, what is the probability player A wins a serve? Let's call it little a. B, float input, what is the probability player B wins a serve? Let's call it B. And int, notice int, input, how many games to simulate. So these are the pieces of information. So let me make sure my function is syntactically fine. So let me test that it is syntactically fine. I will say get inputs function. It doesn't take any parameters. So I'm going to invoke this when I compile this file. That's the purpose of this last line. Save, run. What is the probability player A wins a serve? Say, I don't know, probability is a number between 0 and 1. So let me give it 0.7. For probability B, 0.65. Let's see. How many games? Pretend I want to play 200 games. So there was no problem here. Okay. So everything was fine. Notice A, B, N, these are local scope variables. Okay. So we have returned the variables to prob A, prob B, and N. So let's see. Will A say anything? No. B say anything? N say nothing. All right. Because these are local scope variable. Okay. Now, so the values have been returned in here in the main function. Okay. But I'm not invoking main function here. Now, I want to simulate n games. Now that seems to be a big problem. Okay, what does it mean to simulate so many games? Okay, well, it should be as good as simulating one game several times. So let's try. Okay, we got the inputs. I should have erased it. Okay, now simulate n games is same as simulating one game several times. So let's try. Okay. Simulate n games. I'm going to take number of games, probability for A, probability for A. So here are comments. These describe what this function simulate n games will do. Okay. Simulate n games of racquetball between players whose abilities are represented by the probability of winning a serve. Returns number of wins for A and B. So you want to return number of wins. Now, at the beginning, wins for A and wins for B, they are all equal, both equal. N is the number of games. So I'm going to play n times. So that's a for loop for I in range n. Simulate one game. You simulate one game for probability with the given probability for A, probability for B. You will get a result number of scores for A, number of scores for B. All right, so one game we want to be able to simulate. If the score for A is greater than score of B, then bump up the number of wins for A. Otherwise, bump up the wins for B. Now, mind you, you see, you're not going to have a draw because you have 15 points in each. So you're not going to have 7.5 points. So you're going to have 7, 8 or 8, 7. You see, the best case scenario, whatever. So there is no option for a draw or a tie. So score A is bigger than score B, or else covers the option score B bigger than score A. Okay, so wins A and wins B have to be returned. Okay, so you got inputs here. So looks like I need to simulate one game. So I need a definition of simulate one game. You see how we had to define a new function to play this, right? So I have to break down simulate n games to a smaller piece, simulate one game. Right now, I don't know how, so I'll leave it there. All right, so pause, simulate one game. Okay, suppose I have simulate n games, I'm sorry. Okay, I'm going to play 200 games. Probability of A is 0.7 and probability of B is 0.65. Say pretend. Let me see whether I'm able to invoke these two. At least the syntax. Also probability for probability A wins a game, I don't know, 0.7, 0.65. How many games to simulate? 200. And something went wrong. Cannot unpack non-iterable. Which one? Simulate one game. I cannot, because right now simulate one game has to be defined. Okay, but apart from that, it seems there is nothing wrong in terms of indentation, etc. So we'll have to work on simulate one game. Okay, so here we go. Okay, simulate one game. Okay, now you're going to simulate a single game of racquetball. Okay, serving, always we start with A. Score of A is 0, score of B is 0. Well, as long as game is not over, that is not game over, score A, score B, right? So game over is a new function. You see how it's developing now. Define game over A, B. All right. So score for A. If the score serving for is A, suppose player A is serving, choose any random number. If the random number is less than probability A, then bump up score of A. This is the simulation for random success. Okay, random number that you pick is less than probability of A, then bump up score of A. Otherwise, serving is B because A lost the rally, it started in the score. So serving became B. Now, this is when serving is A. If else means if serving is B, if a random number is less than probability B, then bump up the score of B. Otherwise, that is B has lost the rally, serving goes to A. Okay. Now return score of A, score of B. So those are the scores that you want. Okay, score of A, score of B. In order. See, first one is for A, second one for B, because that's what you want. First one for A, second. So now let's define game over. When is game over? When is game over? Oh, this one. Well, game is over when the first score is 15 or second score is 15. That's all. Return the Boolean value of this expression. Little a is, notice it's double equal. That is, this returns a Boolean value. It's a conditional. Okay. All right. And lastly, we are ready to print the summary. Summary, that is, once you have wins. So now no need to unit test. We could have unit tested, but let's run the main function. Okay, run it. Okay, what's the probability player A wins a serve? Say 0.7. What's the probability player B wins a serve? Say 0.69. How many games do you want to simulate? Say 200. So A, in this simulation, A 114 games, B 186 games. So notice the probability A would win was just a little higher. And yet A won more than, substantially more than B. So this is just one example. Okay. Have a look at this code and notice how we started with a small piece and design, we had to break it into several pieces, but when it came to implementation, we went through one tiny piece at a time. Okay, until next video.